Hi everyone, welcome to my channel and I am Subhash Chandran. The thumbnail that you have seen for this video is not a clickbait thumbnail. It really happened to me. Indeed, it really took 10 years for me to understand the core principle of the designing activity that I am doing in piping design. I know there are lots of such candidates in the market, in our industry, trying to understand what they are trying to do in piping design. So I hope with this video, I can answer them, I can support them, and I can really appreciate them for what they are doing actually. So let me share my experience with you. For some time over a period of my journey in piping design, my understanding was producing the plot plan, producing the piping layout, and producing isometrics and 3D model are the core designing activities in piping design. But logically, when I came around 8 to 10 years experience, I was trying to answer myself, these are the output of the design. So what is the design that we are doing in piping? The drawings, 3D models are all the output of your design deliverables. So what is that design thing that you are doing in piping design? I seriously wanted to answer myself because being a piping design engineer, the day in and day out, I am into the piping design. So if I don't answer my query within myself, so I will not be able to progress myself. So I want to know what I am doing. Whenever I go for an interview, I used to tell them I prepare a plot plan, I prepare a 3D model, I review the piping drawings, prepare specifications, data sheet and TBEs. There are many piping deliverables are there, right? So I used to explain that. But one day, and this happened to me, that I wanted to understand by doing this deliverable what I am trying to do it. So I was analyzing it, what I am doing in piping design, what is the core value in order to deliver these outputs in piping design. So it really took nearly around 8 to 10 years. So by the time I am 10 years experienced, I was able to answer myself for all these doubts. So let me share that experience with you. Let me share what exactly in piping design we are doing as a design thing. Drawing preparation is different, 3D modeling is different, preparing a data sheet is different. These are the output in order to achieve the construction, in order to support the construction, in order to deliver the materials so that the construction team can build the piping infrastructure. But these are not design. Design is the ideology of your plan. Design is the narration of your planning of what you are doing actually. So you are here in order to plan something by putting your ideas, by putting some solutions actually, and that solution converts into a drawing and 3D model, a data sheet or specification or n number of things. But what is that idea? You understand my point? So now I will share you those ideas that I have learned over a period of 10 years. See, the first thing is that in any piping projects, as a design engineer, the key role of design engineer is to address the requirements of clients. Am I right or wrong? You have to understand what the client requirement is all about. What is their expectation? If the clients are planning to install 2 equipments, you have to understand where they are going to plan. Is there any feasibility? Is there any constraints, or is there any time limits when they are planning? So you have to understand the core requirements of the clients. Not all the times that client may be right, client may also go wrong actually. So you have to understand the requirement and explain the client, these are the constraints you have. So for this, either you have to maximize the scope or you have to minimize the scope. This understanding bringing is the role of piping design engineer. I understand that it's not only about the piping design engineer. In a project, if you are working, you have to associate with other disciplines also. But the key intent is that as a piping design engineer, we have to know the layout point of view in terms of piping design deliverables. You should able to visualize yourself in order to guide the client that these are the constraints so that you cannot do this. In order to do this, you have to either maximize or minimize. So the primary intent of design engineer is to understand the scope and align with the client in order to make it possible to execute actually. See, you bring me a scope, and if the scope is not able to be executed, then there is no use of executing the overall project, right? So the vital role of the design engineer is to clearly narrate the scope and make sure that the client understands it, and make sure that this is executable in a way that the construction can be 100% completed. So this visualization only design engineer can bring, because design engineer aware about the various phases of design, right from the scratch and right to the construction and commissioning and handing over to the client. So the primary role of design engineer is to address the requirements of the clients. And second, the major role of design engineer is cost-effective design. What is cost-effective design? The clients may come up with n number of scopes, but the ultimate aim of the client is to complete the whole project within a given budget. If you are going to exceed the budget, then the client may not be able to construct this particular scope. So your intent is that you should plan the activities, you should plan the design, plan the materials in such a way that you can complete within this budget. At least as a piping design engineer, you can plan the piping part. There are other parts also, like equipments are taken care by statics and civil designs are taken care by other disciplines. But as a piping design engineer, you are the control of the piping layout. You are the control of overall design preparation. So cost-effective design. To give a simple example for cost-effective design actually. See, instead of providing individual support for individual lines, if you can group the bunch of lines in one particular pipe ways, you can save lots of cost in pipe supports. Instead of planning individual routing for different lines at different locations, if you can plan in such an order that all the lines goes and follows in one particular way or one particular route actually, that will save lots of cost in terms of structures and civils actually. Finally, we are trying to achieve the overall cost of the projects. It could be from any way, and you can minimize the number of fittings. Try to analyze the possible routing so that you can consume only minimum number of fittings. If you want to learn about pipe routing, I have made a course for pipe routing for oil and gas, and this particular course is not only for oil and gas, it applies for n number of industries across the world. You can use it in any particular industries, not an issue. Especially in this course, I was highlighting how exactly you have to do the pipe routing, what are the parameters that you have to consider as a design engineer, because decisions needs to be taken by design engineer. If design engineers are not in a position to make decision, then we cannot call them as design engineers, right? So in this course, I'm trying to advise and I'm trying to explain the design decisions with respect to certain parameters, specific parameters with simple graphics. You will be able to understand very quickly. You don't have to read 200-300 pages of books to understand the pipe routing. I think according to me, there is no such books available or no such course available in this world. I am confidently saying that. There are courses addresses about the piping design, but there is no courses available in the world specifically focusing on pipe routing, because pipe routing is the key skill for a piping design engineers. If you want to name yourself as a piping design engineer, the one thing you have to learn is that pipe routing skill. Without pipe routing skill, we cannot address ourselves as a piping design engineers. So this course will really help you to understand how to route in different locations, different equipments, what are the parameters, how to make decisions, so and so, and for different instruments. There are various options, various areas that I have covered it. There are many topics that I have covered it. You can go and check. I will give you the link of that particular course in the description of this video so that you will be able to watch the preview video, understand the course, and then proceed for whether you have to buy or not, because that has a list of contents that will help you to understand what you are going to learn. Okay. So now coming back to the topic, actually cost effective design. So cost effective design could be done in various ways. You can reduce the number of fittings, you can reduce the number of the supports, and even you can reduce the length of the piping. You can propose the equipment location, which is near, so that you don't have to run the line for 500 meters or 1 kilometer. Imagine that you could save a half a kilometer of a piping. You're not only saving the material cost of piping, you're saving the construction cost of piping, the material cost of particular pipe and fittings actually, and the workability and workmanship cost for installing those construction piece of piping. So there are n number of costs associated with even a 1 meter of a pipes actually. So it's not directly a material cost to material cost. So cost effective design is another aspect of piping design engineers. And what is the third one? The third one is space aesthetics. What is space aesthetics? Space aesthetic is one of the fantastic things that only piping design engineers can do. I'm telling you. If you go to a plant and if you admire the design of the overall plant, then you have to give a big applause to the piping design engineers, because piping design engineers decides the overall aesthetic of the plant. You have to give a big salute to piping design engineers who have worked on this particular plant, because aesthetic means how to utilize the overall space, where to put an equipment, where to put a pipe rack, where to consider the crane area, which side should be the entry of the plant, which side should be the exit of the plant, where should be the material dropout area, and where should be the road access, where should be the safety shower location. So there are n number of factors, but all these factors are designed, assessed and fixed by piping design engineer. This is one of the fantastic skill that all piping design engineers have to possess, and if they have, and it is really an appreciable skill. So space aesthetic is one of the fantastic thing. It's to make it very simple actually, how you are utilizing the space as a minimum, and by reserving the certain few spaces that are also shall be used for the future expansion. So if you are not good in utilizing the space, then your overall piping layout will look messy actually, and you will get a lot of comments from clients. But if your piping layout is so organized, like you are grouping all the pipings, grouping all the equipments together, and grouping the instruments accessibility. Say for an example, if an operator goes to one particular location, and he will be able to access many of the equipments pertaining to that particular equipment or that particular piping. So you have to use the space in such a way that you systematically organize the overall equipments and pipings in a way that will not stop others in performing certain activity in that particular space. This is very important, space aesthetic. And the fourth part is to ease operational requirements and maintenance requirements. See, we are building a plant in order to produce something, but these plants needs to be operated and monitored and maintenance to be done in order to safely do the production and day in and day out. So operators has to access these valves, equipments, and maintenance contractors and maintenance team have to monitor these lines and replace the equipments to do the periodical maintenance. For all of these things, there are certain requirements. So only piping design engineers can think about all these factors and design the overall space with a cost-effective design, so that the clients will be so happy to accept this design, because you are meeting all the requirements. There is not one particular parameter. You are meeting the tens and thousands of parameters, but still you are being able to deliver your design within the reserved budget, and which is a cost-effective design. So ease operational and maintenance requirements is the other thing that we are doing. And the last one we have over here is design to make construction easier, which is the primary intent of the design. When you are designing something, it has to be constructed. If you are designing and which is not possible to be implemented or constructed, then there is no use of designing, correct? So what is it that you are doing to make the construction more easier is understanding the constructional constraints basically. So basically you have to ensure that the crane space is available. If you are planning an equipment installation, you have to reserve some crane space. If the crane is not able to be located near to this equipment, so you cannot imagine the construction team to install this equipment effortlessly. It happened to me that once we were reviewing an equipment location, there were no crane space, and it was even reviewed by the construction team, and we got a comment also. To replace this particular equipment or to install this particular equipment, they have to bring a huge crane because there is no space considered near to this equipment. If there is a reserved space right in front of the equipment or near to the nearby equipments around anywhere, actually, they can bring a small cranes. Because the proportion of the crane is something like the distance increases, the capacity of the crane needs to be bigger. Say for an example, if you are going to handle half a ton of an equipment, if the equipment weight is half ton, you can handle that with nearly 2 tons of a crane, provided your crane location is near to this equipment. But if the crane location is not near to the equipment and you have to place this crane far away, the boom length of the crane cannot be able to lift this particular equipment even if it is lesser than half a ton. That is the principle of the crane. You have to bring 13 or 25 ton crane for that to lift this particular equipment, which is an additional cost. So being a design engineer, we have to consider all these factors. So this is the 5 realization that I was able to understand when I was about 10 years. It really took 10 years. This is true to my knowledge because these are not learnt and or taught by anyone. You are trying to, when you're trying to more explore, when you're trying to understand what you're doing, and when you're trying to dedicate yourself in the designing, actually, you are trying to understand what is the principal design that is calling for. So I hope this video will really help all the piping design engineers about what you're doing. Just don't bother about what you're doing is only about the piping drawings and 3D models and materials and the bill of materials, and this is the output of your design. But your design principle is, it revolves around the 5 important things that I've told you now. So these are the 5 key skills that we are doing in every day in day out of our design activities. So I really appreciate all the piping design engineers who are working to build a beautiful plant and who are working to build the hazard-less plant, actually. And I really appreciate you once again. I will meet you in another fantastic video. Until then, bye from Subhash Chandran.